Welcome everybody. I'm really thrilling to see so many people, and I would also like to welcome the people behind the screens. I'm really happy to talk to you about something that's really close to my heart is data management, but I felt like it's not a talk where I can talk about the deep innards of data management system, but it's rather like a talk where I can kind of explain what fascinates me about this. And so this is why I'm here to talk about the ancient art. We have some things to cover. I will first explain how did I get here, because that's also everybody wants to see that, I think. Then I will talk about how did we get here as a sort of society, as a field, where we are in general, also why I'm personally interested in this particular subject. And of course, I will also try to make some bold predictions that may or may not become true, we will see. But since this is the university, I'm also really trying to give you an insight on what I try to focus on when I teach the students next year in the spring. Let's start with the first part. How did I get here? Well, I stood up at some point from my sandbox. Very young Hannes says hello. I actually identify as a so-called Schwabe. The Swabians, as they're called in English, they are remnants of a Roman age tribe from the Alemanni sort of department. And the descendants of the Schwaben, they now live in southern Germany, and they speak a very peculiar dialect. For those of you who have never heard it, you can ask my wife about the details. It's also true that, unlike maybe people in the Netherlands, we don't normally move a lot. So people have stayed there since the Romans, essentially. And I have to also tell you that the university has made a grave mistake by hiring me, because it is well known that the Swabians only reach adulthood and intelligence on their 40th birthday. And this is shown in this quote, which means they get it rather late. So I can only apologize for the following content. The Swabians are, however, also known as tinkerers, Tüftler it's called. Once they are 40, of course. Once they are 40, they are known for extensive tinkering, slowly perfecting something. And I think that is very much an academic value. For a fun fact, maybe, that you didn't know that Gottlieb Daimler, who did not only invent the first four-wheeled car in the area, but also invented a motorboat, which is something I think that the Dutch people can appreciate. Being a tinkerer is a badge of honor where I come from. And it's very interesting because there's this sort of natural, I would say, conflict between a tinkerer and formal sort of research. But I'll get back to that. So if you put a tinkerer, in the world, what will happen? So around age 13, I'm not entirely sure anymore, my father sold me a discarded ancient computer for 500 Deutschmarks. Which is why he's the businessman and I'm not. The fun fact is not that he made me pay for it, it's that there was a password set, so it could actually not be used by anyone. But I think we should not underestimate motivated 13-year-olds. Who here remembers this game? Is there anyone? Oh, that's quite a lot of people. Okay, that's excellent. This is called Nibbles. And Nibbles was a game that came with the MS-DOS operating system. For the young people, that was what we had before Windows. And amazingly, for this talk, I got this to run on my MacBook here, which was fun. But the cool thing about Nibbles was that it actually came with the source code of the program. And this is today totally unheard of. We'll buy a game and it will never come with the program code that was used to create the game. But this was the case for this game. And I actually taught myself programming using the source code of Nibbles. And it's the language called BASIC, and it's very bad, according to Dijkstra, I think. But again, do not underestimate it, motivated 14-year-olds, especially before we had the internet. Later on, I became a PHP developer, which is also something people now sneer at, but then it was the hot thing to do. But PHP, all amazing as it was, it could not do a lot of things. For example, it couldn't actually save data anywhere. It was very, very cumbersome to do that. For that, you had to use something called MySQL. And it used a language called SQL, and it was very, very strange to me at first, but I quickly got very excited about SQL. In fact, I got so excited that this was my actual license plate back in the day. So I was so enthusiastic about SQLite, this was clear. You know, the Germans, they loved it. You can change a license plate, and anyways. But because of this enthusiasm about technology, I went on to study computer science. And I would like to acknowledge some of the great teachers I had over the years. So, for example, started at University of Stuttgart and went then to the Humboldt University in Berlin, as is common for people from Stuttgart. And there I was research assistant to Olaf Hartig, who I think is watching, and Johann Christoph Freitag at the Humboldt University. I went then over to the Free University, the FU Berlin, to get my PhD under Robert Tolksdorff. And then, as it has been mentioned, I went to Amsterdam and worked under Martin, Peter, and Stefan, who are here today. I'm still very fascinated with data management systems, something about tables that somehow speaks to me. It was also mentioned that I went to Amsterdam. I love water. We live on a ship. I met wonderful people, some of which are here today as well. And I met Mark. He was first my master student, then my PhD student, then my postdoc, and now he's my co-founder. I would not be here without you, so I wanted to just make that absolutely clear. But with Mark, we started this project called DuckDB in 2018, and it's really a bit of a departure from academic sort of practice where people try to start software projects in data management systems, and they do not only just write software, but they also try to get it used. And there were, of course, precedent in database architectures doing something similar. But now this is it's a piece of software people download millions of times every month. And it's the fastest growing database software project ever, as far as I can tell. And that is, I think, what really fascinates me, is to get something out there in the world and get it used. Why am I doing this? Okay, this is how did I get here? Why am I doing data management in principle? I've mentioned that I'm really excited about the language SQL, but that's not enough. So here we have this situation that data management systems, and I try to show this here on this picture, where you see the modern city, and you see all these incredibly complicated layers of infrastructure and technology that make it actually work. Data management systems, the kind of systems that I work on, are some of the most complex pieces of software out there. They are probably more complicated than operating systems, although I'm not sure about Microsoft Word. The jury is still out on that one. The data management systems are a fundamental building block of modern society. We could not do anything without those things, and yet they are mostly invisible. We cannot run any sort of application, we cannot run a government, we cannot run a military, we cannot run a space program, anything. They are fundamental pieces of infrastructure, and working on them, in my opinion, is fundamental research too. It's also interesting to know that data management systems are a $1 trillion market, and sometimes it's good to be in a $1 trillion market. And it comes back to what I said earlier about the tinkering, because in data management systems, the mastery of practice is hugely important to their success. You cannot build a database management systems with a team of theoreticians. It's just not possible. I know that some people are going to crucify me after I walk out of here, but this is really something I strongly believe in. You can also not build a successful database management system using a team of programmers, because it's also not going to work. There is some sort of artisanal sort of grasp of theory in making data management systems. You need to be able to experiment. You need to keep trying. At our company, we call this head bashing, where you basically throw your head against a problem until it gives up, and you move on, right? You move to the next problem. So you need a team of tinkerers, if you will. So that's why I'm doing this. So now I want to make good on the promise and talk to you about how did we get here to this point where data management systems are such fundamental building blocks of our society. And I want to start with this. And this takes some time to take in. This is a tablet. Sounds a lot like a table, doesn't it? It's a tablet in a language called Proto-Cuneiform. It's Proto-Cuneiform because it's not actually a language yet. It was excavated in Uruk, which is in today's Iraq, about 5,200 years ago. It was made 5,200 years ago. This is, by the way, approximately 1,000 years before the first text that we know. Okay? So what does this say? Well, it says it's a table of an item and an amount, and it talks about hop and barley, which is something I think we can appreciate. This is just a table. And what the crazy thing about this tablet is, in my opinion, is that record keeping, according to the archaeological record, predates literature. Okay, people made tables before they made stories, before they wrote down stories. And there seems to be some sort of a basic need to keep records of things in writing. And it's no accident that these tablets appear as soon as the first serious civilizations appear, because I think we cannot have a civilization without tables. This is a bit of a later example. This looks a lot like an Excel spreadsheet, right? Only that it is 3,500 years old. And it's now they invented a language, cuneiform, and basically, I don't know what it says, but I just really like the visual impression that everybody can recognize of a table. But making things on clay, and while we're very grateful, by the way, that people wrote on clay, because it's the only way we can really see it today, while this was a very, very successful, sort of long-lasting storage solution, the more practical thing was to just write it down on paper. So this is a papyrus from Egypt. It's about 4,500 years old as well. And it's part of the diary of an official who was inspecting the pharaoh's naval station and just wrote down his observations in this spreadsheet. And you would think, okay, so he is in 4,000 years ago in Egypt. Clearly there must be some sort of gradual improvement of table technology of the next thousands of years. But no. Nothing really happened in spreadsheets for a couple of thousand years. Empires come and go. The Romans still use papyrus and ink. The medieval people still use papyrus and ink, or maybe some sort of leather. So there's crickets. Until this guy. The next giant leap in data was Hermann Hollerith. He sounds very German, but he is not actually German. He's American. But his parents emigrated from southwestern Germany. Okay. Hollerith invented a machine called the Hollerith machine, the tabulating machine. Here's a picture, and I showed this picture to somebody, and they said, it's really amazing how somebody actually did a photo shoot for a machine, because it looks amazing, doesn't it? So this is the Hollerith machine, the tabulating machine. And I should tell you a little bit about the backstory, how we got this machine. It's the Americans are many. This is a fact. They got so many that the census they do every 10 years, I believe, in 1880 had taken 2 years to process, because at that point there were about 100 million people, and it had taken 2 years to use the Egyptian technology with the spreadsheet on a piece of paper in order to actually compute the statistics that were vital to keep the country running. Also to allocate money to various things. It was a bit of an important thing to do. And so, yeah, it had taken 2 years. That wasn't great. So Hollerith came up with this machine that used punch cards to basically automate data processing. And the machine you see here on the left, you see a chair, very important. Still today we sit on chairs. And you see these dials up there, and the dials, they basically could advance based on what was on the punch card. In the center, this thing that is a bit of a different color and looks metallic, that's the punch card reader. And on the right, we see a sorting device, which I'm not going to cover too much. Here is the device that was used to encode data. So this is the puncher, if you want, of the punch card. So you wanted to encode some information on this card. You would shove it into this device, you push a button, it made a hole. That's how it worked. And here I have a picture from the actual patent. How this works? Well, you would shove the paper then into under this lever that you can see on top there, and you push down on the lever, and then if there was a hole in the paper, a needle would go through the paper into a pool of mercury. Mercury is not a very pleasant substance, but back then nobody cared. And then whenever there was a connection made, an electrical impulse would go to this dial you see there and would advance the dial by 1. Okay? And this was used for the first time on a large scale for the 1890 US census. And they made 100 million cards, one for every American. And it took them, they finished months ahead of schedule and far under budget. An experienced operator could tabulate 50 to 80 cards a minute. So it's like, today at the Lidl, what you have these people that go like beep, 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 beep. That was the people with the punch cards. And obviously that would still take 4 years if you only had a single operator. But of course you can have multiple operators using multiple machines at the same time. This interestingly harks back to something we still do work today, and it's the single node efficiency and parallelism. These are two things that are still important. They were important back then. But Hollerith really revolutionized the art of data collection and analysis. And I also want to mention that Hollerith is kind of the last time that intuitive understanding of data technology is possible, right? If I go back to this, oops, not lasering people, sorry. If I go back to this picture here, you can imagine, making this with your Cosmos kit at home. You can make a thing that advances a dial whenever an electric connection is made. This is something we can still imagine. But regrettably, everything since is not maybe as intuitive. But I'm going to try to still do that. Anyways, back to history. So the census was a huge success. Hollerith founded a company, the Tabulating Machine Company, which was very successful. It eventually merged with some other companies into the Computing, Tabulating, Recording Company in 1914. This is their amazing logo. Logos were already a thing in 1914. The company is better known under this name. So this is what eventually became IBM. They renamed themselves in 1924. Big Blue was born. I would love to say the rest is history, but there's more I want to tell you about this. First of all, tabulating machines, as the one that Hollerith invented, lived on for about 100 years. This is also unprecedented in technology. This is a picture of the IBM 407. It's a, get ready for a lot of IBM code names. IBM 407, it was the successor of Hollerith's machine using the exact same principles. It was sold for 30 years from 1941 till 1976, which is like, what? You sold a computer for 30 years long? Okay. This picture is from 1975. But then in 1975, or better, in the time they ended, there was actually something else that happened. We had gotten digital computers. Okay, this is something that came out of the war era code breaking efforts. But digital computers were completely ignored for data management because the tabulating machines were so much better, right? But this changed in 1968 because eventually the data processing industry had to switch to the digital computers. And IBM actually got a contract from NASA to do parts management for the Moon program. Okay? And they said, look, we're spending all this money on the Moon program. Let's give some money to IBM. Still, same concept happens today. And they built a data management system, a digital data management system for the Moon program to track all the bits and pieces of their rocket. And this was first installed in 1968 at NASA on the IBM 360. Here's a picture of the IBM 360. I really love how dignified computing was at the time. It's just, you wear a suit. It was clean. It's a far cry from today's computing environment. So IBM basically turned around and took the system that they built for NASA and launched the world's first commercial database management system called the Information Control System and Data Language / Interface, which just goes to show that computer science people are horrible at naming things. ICS/DL/I. Okay. Thankfully, somebody sort of fixed this in 1969. It was renamed the Information Management System. And IMS is, by the way, still around. Like, these things never die. IMS, the thing that they built for the Moon program, is still in use. I've read that Chinese banks are still big users of it. Okay. But IMS was a really great system. You could manage data. You could, organize the parts for a moon rocket with it. But it still had this hierarchical way of representing information, where basically you had to choose what you want to organize your data with. For example, you had to say, we'll have the data by customer, and then we have that by contract, then we have it by order, and then we have it by line item. And this was kind of this tree of information that you had to build, and you also had to always follow this tree of information when you wanted to look at something. So it wasn't straightforward to say, hey, give me all the orders in this system, because you had to first go through all the customers, through all the contracts to find all the orders. So that was a bit problematic. Thankfully, somebody came up with a better abstraction. So in 1970, Edgar Cott came up with this relational model where this is actually abstracted, where we just have a sea of tables, and it actually was a much better fit. It was a revolution. It's still what we use today. And it's very interesting for analysis of data, because very often we do not know which way we're going to sort of look at the data. Also, Ian will like that this was published in Information Retrieval, which means that information retrieval precedes databases. From there on, we had a bunch of very successful systems. We had System R in 73, 79, Oracle, a company still, many will know, it's 83. We have DB2, which is an IBM product that is also still around today. People use to all sorts of things. It was always really going well. People were having systems, people were making a lot of money with them, but then this happened. So this is a picture of the first Google production server. And I think it's fair to call these people tinkerers, because it's one of the pictures I like to show people like that are a bit of an engineering background and say, look, this is what revolutionized the world. It's very bad. So they can maybe see how this board there on the bottom is bent. Yeah, I don't know if you know a lot about digital technology, but you shouldn't bend your things, okay? Pro tip, your phone will not like it. But Google had to build these very cheap servers because the business model essentially was to sell advertisement. And they actually didn't want to build this. I think there's this somewhat apocryphal story where they asked IBM and said, give us a system to do this. You do this analysis of the web, all the websites in the world for us. They said, sure, just give us $10 billion and we'll do it. But of course, they couldn't do that, so they just stacked a bunch of parts and then wrote their own sort of software to process the internet. Then we got MapReduce. So this is now a bit somewhat technical slide, I apologize. Basically, Google invented their own language and infrastructure to process large amount of data on these very sort of questionable pieces of hardware that they had. And that really changed the world, because we suddenly had the means to crunch through huge amounts of data in a very short time. This started about 20-year long-lasting big data hype that's now, thankfully, a little bit less dramatic. You had papers like the unreasonable effectiveness of data, which got everybody excited, I think. Somebody who is in the room has proclaimed big data to be dead, and I agree. But I think this is just an interesting sort of position to be on now, that we have sort of seen all this sort of this line of technology brought us to the present day. We had big data, now we have it not again. We still have relational databases, but where are we going? Okay, so this is the part where if you're gonna record this, you can make fun of me in 20 years if I'm wrong, or if I'm right, I get to point to this on Twitter in 20 years. Time for bold predictions. So I will make a couple, and I will hope one comes true, and then be able to tell you I told you so. So the first one is a German word. It's Flugscham. It's a very German word. It means that you are embarrassed to fly somewhere because of the impact on the climate that your flight is going to have. It's people make fun of the Germans having words for everything. This is one of them. I have a feeling we will see a similar word emerging at some point, maybe only in German, but for using more amount of sort of computing resources, more computing than we absolutely have to. The amount of sort of energy and resources that go into computing right now is pretty ridiculous. And how some trends are going to survive this, I don't know. And this is actually caused, like my prediction for this is actually caused by looking around our office. So if you look at this picture, it's Amsterdam Science Park. You can see our office. It's up here. It's almost not visible, right? And then you can see these ginormous towers there. And these towers are data centers, okay? This big thing back there and this big thing down there, these are all data centers. The data centers dwarf the buildings that are for the humans, right? And we can't see them. And it really got me thinking, are all those computers strictly necessary? How many, okay, technical term, 10-node Spark clusters are running pointlessly? And just to give you a small example, in the big data era, we would have this horizontal scaling approach where we have a bigger problem, we add more computers, and we sacrifice everything else for that. And with DuckDB, we take the opposite approach where we say, you have a bigger problem, just get a slightly bigger computer and you'll be fine. And the impact of that, and sorry, I cannot have a database talk without some performance numbers. I do apologize. If we run a standard benchmark on Spark with one CPU, it takes 45 seconds. If you run it on DuckDB, it takes 10 seconds. If we take instead 10 CPUs like this laptop here, it takes 11 seconds in Spark, it takes 1.5 seconds in DuckDB. So I think we will get to this point where we're using something that will basically give you a 5x slowdown for a data problem be no longer acceptable because of the Flugscham, right? How can you live with yourself when you're burning all this energy and computing resources essentially on weird things? It's like, I try to come up with a metaphor. It's like tying 10 hedgehogs together and hope they overtake the rabbit. Another thing I want to predict is that human scale data is actually going to eat everything. So I did a thought experiment, and I hope I didn't make any mistakes in my math because it's difficult. Here's the experiment. If we assume that a human typing speed is about 200 characters a minute, okay, I looked this up, this is kind of an average typing speed. And then we just take the whole working population of the Netherlands, it's about 10 million people. And the work year in the Netherlands is about 100,000 minutes. And then we multiply that all up, we end up with 200 terabytes of data that we could produce. If we were to hire the entire working population of the country, they would all spend the entire year typing in data into computers, and this would be the data set that was created by this. And after compression, which we can apply to this 200 terabytes, we would have something like 60 terabytes of data. It does sound like a lot, okay? But it actually isn't anymore. These are standard hard disks you can buy on Amazon for 300 euros, other shops as well, I'm not trying to, These are hard disks, each has 22 terabytes of space. You can buy 3 of those, and you can put them in a computer, and you can put all this ginormous data set that we've just created at the cost of the Dutch sort of economic output, and can shove it into these 3 disks, and it will sit there happily, and we can analyze it no problem on one single computer. So there's no scale-up required. The banana is just for scale, so you believe me that these are fairly small, right? In 2 years, this will be 1 disk. And in 10 years, it will fit on a laptop. The humans are not going to get better at typing, okay? Or maybe just slow, like, okay, fine, get some AI assistant, it will be a little bit faster, but it's not going to have orders of magnitude increases. So, plus the growth in population is fairly slow. And so it means that the computing resources are growing so quickly, and even things like this laptop, that we will be able to actually put all meaningful data sets on 3 of these things in a banana size. So my prediction is that it's just computing scale will eat all meaningful data sets. And this, I think, is particularly true given that the data sets that we actually care about tend to be the ones that humans have typed in something. Okay. teaching. What am I going to teach at this wonderful university? I think one thing I want to teach is impact, and I was talking about this at CIDR already. Impact into the society. And when I was here and talked to the leadership of the university, it was a very good fit because it's one of the mottos of the university is to empower people. And I think as a computer scientist, I want to empower people to do more, to be more impactful, to actually make a change in the world. And that, to me, can come in many different forms, but I think it should be our driving instinct to have impact into the real world. Regrettably, the rest of the field disagrees with me. I don't know how that happens. But if you take the gray circle to be the field of data management, people really zoom in on this like small black circle inside of it and work on join algorithms. People also spend a lot of time, moonlighting in other fields on these circles around it. But they totally forget that the user's problems are in this red circle here, and nobody spends any research time on that. And that's really a problem. I call this the pain, but we need to be better at seeing what people struggle with out there. And let's work on that. Let's focus on the problems of the 99% rather than solving Google's problems yet another way. And one of the ways in which we actually think about this, and in DuckDB, is the sandwich picture, where we think about, okay, the research field for the last 50 years or so has focused a lot on this sort of the patty part of the hamburger, and they spent all this time, optimizing that to hell. But nobody has ever really thought about the end-to-end user experience. But that's where the impact is. That's where, that the little things matter. The tinkering is required, and that's what's going to give us impact and change how people look at data. The other thing that I really want to show, that I really want to teach students, is critical thinking. And I know everybody says this, but I perceive a lack of critical thinking in computing sciences, and maybe all of engineering disciplines, especially when taught at the university. We spend a lot of time saying what can be done, and we don't spend a lot of time thinking about whether this is a good idea. It doesn't have to be the climate angle. It can be anything. It can be, is this good for people? Is this good for the climate? I don't really care. But we don't really critically assess technology, or we don't teach it, at least in my experience. We don't teach it to the students. So I want to show you some examples on where critical thinking failed us all. So here is Google Trends. It's a website where you can just type in words, and it will show you the interest in terms of Google search queries over that thing over time, right? So here, if you look at blockchain, for example, you see this blue line that that peaks up somewhere in 2019 and then slowly goes down. Okay. Big data, it's a bit hard to see on the slide. I apologize. Google made the colors. It's a bit of a smaller bump, but it's going down, so that's good. If you look at artificial intelligence, the hype, absolute hype term right now, it's something that's going up. Although I note that the blockchain hype was way bigger than the AI hype, at least according to the Google Trends, which is an interesting observation. But blockchain, these are two screenshots from news articles I found. A US company has turned a former coal plant into a gas-fired Bitcoin mine. Bitcoin miners revived a dying coal plant, then the CO2 emissions soared. How? I consider this the biggest disaster in computer science in the last couple of years. How? This is horrible. This blockchain stuff was horrible for the environment, for society. It was a solution looking for a problem in the first place. Yet everyone jumped on it. And why do we do that, right? Why can't we just say, stand up and say, this is a bad idea, we don't want to do it? I would argue that we're doing it again. We have the same enormous usage of computing resources in AI. We have the same hype. We have the slightly less ridiculous idea, but how much less ridiculous it is remains to be seen. But what I really want to teach students is to critically think about technology and say, okay, we want to really think about, is this a good idea? Also, is this implementation any good? Is this piece of software useful? Is it something that the Americans use and therefore it must be good? Or is it something that is actually good? I mean, there's a lot of sort of, thinking that can be, in my opinion, greatly improved. What I also want to point out is my wife is a construction engineer, and real engineers, not computer engineers, real engineers. Some more in the audience I see laughing at this. Real engineers cannot just use crazy algae-based concrete for the next bridge project. Okay, there is rules that prohibit this. There is like also certification happening. Yes, it would be very cool if we could make our bridge out of algae-based concrete, but we can't. Okay, there's rules. We, as computer science people, we put the latest experimental AI stuff straight into production and don't even blink twice. We need to be less juvenile, I think, in that regard, if we're going to be, taken seriously as an engineering profession, which, me being here as the professor of data engineering is something that I deeply care about. That concludes the rant. Okay, so I want to switch gears a bit and actually thank people. I would not be here without the people around me. And I'm well aware that I can be very difficult to work with sometimes. And I would like to thank everyone for their continued patience. Some people I want to mention individually, but if you're here, you consider yourself thanked already. It's clear to me that it is difficult sometimes, and I want to just appreciate that you stick around. Here, this is me, by the way, on my first day of school. Keen observers will note that I decorated my traditional self-made celebratory sort of thing with a boat. That's on brand. And it's funny because I looked at the pictures to show, and this is the first day of school, all these years away, like, 33 years ago. But today feels very much like the last day of school somehow. I don't know, I have this vibe about it being the last day of school, even though nobody's asking me difficult questions later, maybe later, but not now. And I want to thank my parents, Connie, who is here, and Rolf, for getting me, to this point. Rolf cannot be here, regrettably, for medical reasons. I also thank my siblings, Lisa and Franz. Franz is also here, for being my very best friends since I can remember. Lisa can also not be here because she's expecting her second child very soon, so she has a good excuse. The dog, by the way, was borrowed. I'm not a dog person. I also want to thank Natalie, who is also here, is my wife, together with our son Moritz and our daughter Florence, who are in daycare right now and blissfully unaware of all of this happening, which is I think. Which is, given that they're 2 and 3, is probably a good idea. Thank you, I would not be here without you. I also want to thank everybody who came up with crazy flag designs, because yesterday I came home and all these flags were suddenly appearing on our ship because everybody sort of made their own flag design and put it up, and I had no idea. I was very touched, so thanks for everybody who participated. It really meant a lot to me. I want to thank more people. I want to thank my aunt and uncle, Hans and Gisela, who are also here today. Mark, but I've mentioned you already, so I'm going to make it brief. All the mentors I had over the years, I've mentioned some of them. It's really been amazing. Again, I realize I'm not the easiest person to work with, and I think I'm even a worse person to supervise. So I want to thank all of you for your continued patience with me, and future patience, because Ian gets to do this in the future. The amazing team at DuckDB Labs, some of you are also here. Really, it was a privilege to work with you all, and I'm really excited about where the road is gonna go in the future. Ian, for bringing me here in the first place. Thank you again, and of course everyone who came. That's all of you, and is watching online. I think it's about breakfast television time in the US, so I think hopefully some people enjoyed it. And with that, I would like to thank you all and keep on my Rowan Wizard hat.